family, hello. Welcome and welcome back, architectural design community and all you lighting sophisticats. Welcome to ORA Shorts, and thank you for joining us. Today, we're going to look into two topics that are currently hot and go hand in hand. In a bit, we'll have Steve Seligman, Vice President of Specification Sales at Forum Lighting. He's going to help us understand the ABCs of UVC and UVA. Yes, UVA, and how to effectively engineer the invisible light technology into today's human-centric lighting applications. But first, we're going to talk with Cheyo Rogers, who is the Director of Business Development for the Northeast region at Igor, Inc. Cheyo will reveal the value proposition that power over Ethernet and enhanced connectivity can give to lighting, UV disinfecting routines, and other building systems. Igor works with Cisco Systems at the forefront of digital smart buildings as a digital sealing partner. Igor's flagship product, Nexos, is PoE-based IoT smart building platforms that incorporates the hardware, software, and cloud analytic components needed for a digital building backbone. Nexus delivers a superior smart building network. For those of you who have not been with us before, at the end of each of our presentations, we're going to have a short Q&A. So please drop your question down into the chat bar below, and we'll get to those when the speakers are finished. And by the way, you may want to use the speaker view option at your end to adjust what you see on your screen and better see the presenter's visuals. Finally, after these two speakers present, we're going to share which design firms accepted our Chit Chat Challenge and are headed off on the ORA Odyssey. We're going to reveal the missions, themes, and participating manufacturers. Please stick around to see who is going to literally help save the world. All right, let's get started. I would like to introduce Cheyo Rogers, who, as I said, serves as the Director of Business Development excuse me, for the Northeast region at Igor. In his role, he collaborates with reps and channel partners to grow the Northeast territory. Some in our audience might know Cheyo, as he worked several years at Siemens and Lutron, helping to grow Lutron controls and IoT solutions here in New York City while working at Lutron. Cheyo also was part of the specification team, calling on electrical engineers and lighting designers while managing projects. Cheyo holds a bachelor's degree in mechanical engineering from Rochester Institute of Technology and MBA from Baruch College. Welcome, Cheyo. How are you?
Thank you. I'm doing good, and hopefully we don't have the same technical difficulties as earlier.
And in all fairness, I'm glad it was at your end. It wasn't.
Yes.
Because, like I said, we're working out some bugs. So yes, hopefully we won't have them. So listen, I know there's a lot to talk about, and you have a limited amount of time with us. Thank you for being here. Please, let's jump right in. PoE, it's all you.
Trying to cover a newer topic in PoE in 15 minutes is, I think, half the challenge. So I'll definitely try to keep, a wide overview on that. And really just in the next couple of minutes, just want to give a quick agenda on what I'll be touching on. And the first one is really just giving an overview of Igor as a whole, going into the value proposition of PoE, why it's important. That's always a question that comes up. And then getting into how it works. So going into the technology a little bit more. And then really the last part of it is just touching on our intelligent disinfection solution utilizing UVC. And I'll be a perfect segue into Steve and Form's portion of that. So really just to kind of summarize PoE and Igor, so kind of leaving today, if everyone can at least kind of think of these 4 points when thinking of Igor and PoE, I think we'll all be in a great state. And really the first one is PoE technology. So from Igor's standpoint, we are a technology platform that allows us to power and control various end devices. And lighting is just one part of that. So it's in addition to lighting controls, HVAC, shades, IoT, and various other building systems that come together on this Igor technology platform. And how we're able to do that is through our open architecture system. So being agnostic and open is a big part of Igor's go-to-market strategy. And when PoE first came out several years ago, the fixture selections were limited. You had to use proprietary controls or proprietary fixtures. And again, with Igor, that's not the case. We're agnostic on who we can work with, and that aligns great with Oblani Ranker's line, and then also Form Lighting, who will kind of be talking about the UV portion of it. And then the biggest value add for PoE is being able to future-proof the space. So having a scalable and flexible solution where an end user can easily add on to that solution is key. Not everyone is a Google or a Facebook that can, has a budget or even, the effort to put in a full-blown smart building system. But what about if we can put in PoE lighting day one to meet energy code and meet the human-centric aspect of it? And then day two, have the ability to easily add on other capabilities as budget and as needs continue to grow. And then ultimately, since we are talking about technology, it's really about the use cases on what the clients are looking for and putting together that appropriate solution. In a couple of slides, I have some healthcare focus use cases, and really just to show from a holistic approach how PoE can deliver on that. Starting with Igor, and I kind of like to show this slide as a visual of really where Igor sits in the smart building realm. And as we talked about, Igor is a smart building platform that delivers a cost-effective and flexible solution. And cost-effective two ways. So one, looking at line voltage versus low voltage savings. Obviously, there's a lot associated with there. We're using category cable versus line voltage and conduit. The time to install goes down drastically because it's meant to be a plug and play solution. And also, since it is low voltage and class 2 wiring, can have low voltage installers or contractors do the work versus an electrician. So those labor rates alone are where a lot of those savings occur. And then also, when we're talking about the total building, we're able to eliminate a lot of the redundancies that we might have in traditional buildings. So if we're looking at a building today, you have your separate network and infrastructure for HVAC, lighting, shades, IoT, data, fire, the list goes on. And now where Igor really sits is you're using this PoE backbone to not only control lights, but HVAC, shades, IoT. And again, as we talked about, eliminating the amount of networks and infrastructures that you have within your building. And then Igor's been around since 2013, and to date have done over 250 plus projects in 30 plus countries as well, and ranging from all the different kinds of verticals. And again, the focus today is on healthcare, but the way I like to joke around about, as long as it has walls and lights in there, we're able to offer PoE controls for there. And touching on the healthcare use cases a little bit, and really this is going after improving the patient satisfaction in that space. That's tying in comfort, human-centric lighting. So this is where we get into circadian rhythm. So having tunable white fixtures to mimic the sunlight outside, having that controllability from the PoE system, maybe going into managing the noise levels. So at night, having lower light levels to help from the noise, or tying into other building controls. So HVAC, shades, lighting, all controlled within the room together to have a more comfortable environment. Reduce sun or glare coming in, have the HVAC at set points more, to the preference of the actual patients in that space. Then obviously from a maintenance standpoint, or say a controllability standpoint, reduction in energy costs, because now we're having this real-time data where we can lead to further energy savings. And then really getting into the IoT side of spatialization. So maybe from a healthcare facility or just a building in general, we can better manage that facility. Then getting into asset tracking. Maybe we want to track certain assets such as hospital beds or other equipment, and that can help to improve employee productivity. And again, all of this is capable through the PoE system. And again, you need a lighting control system in place anyways to meet energy code. Why not put something that's a scalable and flexible solution such as PoE? And then lastly, really getting into the environment of the space, but utilizing UV lighting to disinfect that space. And again, this is just another add-on as part of that PoE backbone. And just to show a comparison between a traditional lighting control system and a Igor PoE system. So on the left is something we're all used to today. We have our separate power and communication wiring going out to our devices. So our line voltage and conduit, plus and minus 0 to 10 volt wire. In here, how it's wired, it's how it's controlled. So if you make any changes down the line, like to get into the ceiling, rewire and rezone the system accordingly. And then also from an intelligence standpoint, it's very limited on what it's able to do. At the end of the day, a lighting system is a lighting system. So if you want to incorporate or add on HVAC controls, shades, IoT, well, typically that happens at the front level. You have to integrate these systems together. On the right-hand side is an Igor PoE system, where here we're just running category cable from the network switch into a node. And now that node has 90 watts of power to be able to control and power end devices. So at that node level, that's where we're connecting our occupancy or daylight sensors, fixtures, keypads, shades, all to that node. And as long as we don't exceed that 90 watts of power, we can daisy chain multiple nodes on that same home run. The nice thing about the flexibility of the system is it doesn't matter what device a node is connected to or what port on the network switch. Everything is programmable and talks together. So if you need to make changes to a room, just going into the computer and reprogramming as opposed to having to rezone everything accordingly. Then also from an intelligence standpoint, as we talked about, it's very easy to add on. So let's say day one, you implemented a PoE lighting system, and day two, you wanted to add on spatialization or asset tracking. Well, now you just connect that sensor to the node that's already in there and installed. And now, again, the PoE lighting system is now an IoT system. So that's just really showing how easy and scalable the solution is. And diving into an overview of the actual technology itself and all the parts and pieces that are needed. So starting with the bottom, we have our various low voltage devices. So these can be an occupancy sensor, vacancy, daylight, several IoT, indoor air quality even. Fixtures can range from UV fixtures to tunable white, and then pretty much the full line of normal task fixtures, as I'll call it, from linears, downlights, troffers, pendants. Wall controls can be anything from a touchscreen down to a simple on-off rocker switch. We can get into line voltage control, so controlling receptacles, maybe certain HVAC equipment. And there are still some decorative fixtures, for example, that still require 120 volt power to them. So we could still have power to those fixtures, but still control them as part of the other PoE fixtures. So now you can just have one system that does that whole controllability. And then also adding on motorized shades. So all of these things can be connected directly to the node. And then from that node, it really serves two functionalities. So one, it acts as the PoE driver. This is how we're able to stay agnostic. So the fixtures that have a typical 0 to 10 volt driver, those would be removed. And now the node, we're connecting directly to the fixture board itself. And it also serves as the room controller where we're connecting multiple devices to this node. It's not necessarily a one-for-one relationship. The node also has the ability to be integral or remote mount. So integral meaning we could ship these nodes to fixture manufacturer. They would get installed just like a third-party driver. So now when that fixture comes to a job site, all that needs to be done is fixture hung, and then you run an RJ45 connection into the fixture, and that's it. So it's just as if, plugging in at home your Wi-Fi router, right? That simple. And then from the node, we're going to the network switch. And the network switch is providing that power and communication to the Igor node. And then at the network switch level, this is where we have the Igor gateway or the server. And this is really just a software tool to commission and then also the ability to manage and control that space. And lastly, as more and more clients are really getting into the IoT and smart building world, the optional cloud portals really to manage multiple different sites or really get into the analytics where you can see real-time energy usage, have trends and reports accordingly, or getting into seeing the spatialization over your facility. And then lastly, I just want to touch on the disinfection solution a little bit, and before I turn it back to James, Q&A, and then a perfect segue into Steve and Forum. So from the disinfection solution, just as important as UVC, the actual lighting that's doing the disinfection, it's what controls are you putting in place to do that safely. So on our end, we're utilizing the same nodes, sensor, software that we were just talking about previously. The only thing that's changing is the type of fixture. Again, instead of having a normal fixture, we're using UV fixture. And what this does is through an automated event, so let's say at midnight, to start the disinfection cycle. But before the lights actually turn on, it'll verify with the sensors in that space, whether that's an occupancy, a people counting, access controls. And once it verifies no one is in that space, the lights will turn on for that period of time. Now, those same sensors that were verifying that no one's in that space are also continually checking. So let's say I walked into conference room A, those lights would turn off in that area. And since this is kind of a software platform, you can get those reports and analytics to show you how often a space was or wasn't cleaned. And you can give that, certification or that reassurance to employees or patients in that space saying, hey, this room was cleaned, 5 times this week. So any other questions? That was all on my end. I know, again, I tried to encompass a large topic of PoE that could probably take a whole week into about 15 minutes.
Let me ask you this. Is the 90 watt or 96 watt max on the node an NEC requirement, or is that something you've built into it because that's the typical NEC requirement?
Yeah, so that's actually both. So it's really from a wattage standpoint, going up to 99 watts is the highest you can do to be considered class 2 power. And so our nodes are actually rated up to 99 watts. However, from a network switch standpoint, those typically only put out 90 watts. So that's really where we get that 90 watts kind of designed around today.
Okay, and while you already alluded to that most of the equipment is the same, or all of it, whether you're working with ambient light or with the sanitizing light, it is up to the fixture manufacturer to integrate that technology, but it's still the same sort of SKUs for you guys.
Correct. Yes, exactly. So
yeah. Okay.
Correct. Yep. So it'd still be the same node, and then yes, that's up to the fixture manufacturer to really, if that can be built in the fixture or not.
Okay. Then before we hand it over to Steve, what would you say is the biggest misconception before you speak with people about PoE that you'd like to say, by the way, it doesn't bite and it's pretty safe, as we're already seeing here?
Yes, I would say 2 things. So one is on you're using proprietary fixtures. Again, that's a really big misconception. Being agnostic is really key, especially from a lighting designer standpoint, right? We're not saying you have to use fixture A from this manufacturer to use the same that you're used to, just a new and a better way to control them. Getting into emergency lighting, so being able to do emergency lighting is a big misconception as well.
We do have one or 2 other questions. What's the size of the node? I guess that means the dimensional footprint.
Yep. So we have 2 different nodes. So one is our 60 watt node, which is probably about the size of a deck of cards. And then we have our 90 watt node, which is a linear node, which is probably about 16 inches long or so, and then about 3 inches long.
Oh, so they can't ballast.
Correct. Yeah. So correct. So it's very similar to a linear driver, and really essentially meant to replace those.
Okay, so that might answer the next question, but whether it's a surface mount or a recessed luminaire, would the node have to be visible? And I guess the answer would be, based on what you've told us, not as far as you're concerned, but it depends on the architecture of the luminaire and if it can be concealed.
Correct. Yeah. So obviously from an architectural, standpoint, it want to be hidden, but it can go on top of the fixture, really anywhere associated with that, as long as there's obviously access to it.
Okay. Well, next level technology, really. Thanks so much for joining us and sharing. Please stick around for Steve's presentation. And Really, again, appreciate all of that. Now, coming up to bat is our own Stephen Seligman, Vice President of Specification Sales at Forum Lighting. Forum is one of Igor's newest technology partners. Now, Steve is going to help us understand the basics and the important safety issues of UVC disinfection. Then, that's not going to happen this time. I got it. Okay, good for me. Then show how to effectively engineer the invisible light technology into application. And for those of you who don't know, and this is pretty cool, Steve attended SUNY Farmingdale, where he received the Grumman Aerospace Future Technologist Scholarship. And he graduated as valedictorian with BS in manufacturing engineering. He joined the engineering department at ORA Lighting straight out of school and eventually worked his way up to the director of engineering and then president at Architectural Lighting Division at Illumination Concepts and Engineering. Shazam. In 2008, he joined Forum Lighting as vice president in sales product development. He says he's proud to have helped reshape the identity of the company and to continue and implement the latest technologies into Forum products. And now I would like to welcome back Steve Seligman. Steve, thanks for joining us again.
Thank you.
You know what, I want to, just in case people have to jump, please, I hope you'll bear with me just one second. Two more questions jumped in the queue. One, and they're both gonna go back to Cheyo. What is the status of PoE lighting as emergency in New York City? Maybe, you know, we bounce back to that because that might take a moment. Cheyo, can you field that pretty quickly? Do you know? You have to know.
Yeah, so from New York City standpoint, the DOB still requires line voltage to emergency fixtures, so we still are able to control those emergency fixtures. Throughout the rest of the country, we're able to use our PoE UL 924 solution.
Dig it. Okay. And can PoE work basically with VAV devices, and are there HVAC limitations?
So there are certain HVAC controls that can work. We essentially have an 8-port relay board that can work with various VAV and HVAC devices.
Okay, excellent. Thanks. Steve, thanks for being patient.
No problem.
I do want to jump right in, and I want to cover how you know that the invisible light product will perform in given application. But first, what are the absolute most important things that architects and designers need to know about both UVC and UVA disinfection and how they work?
Okay. I want to welcome everybody today to the ABCs of UV radiation, or the Reader's Digest condensed version. Again, we're going to cover a lot of information relatively quickly, so it's going to be kind of a 20,000 foot view of it. But hopefully, when we're done, you'll have an understanding of what UV radiation is, how it works as far as it comes to disinfecting, some implementation strategies, as well as how we can validate those strategies, which is really important to know that what it is we design and implement is going to, in fact, do what we want it to do.
Excellent.
So why don't we start with what is UV radiation? As design professionals, we're used to working in the visible light range. Visible light is a form of electromagnetic radiation. However, all electromagnetic radiation is not considered light. The visible spectrum, what we use or see daily, that is light. To the right, we have infrared. To the left, we have UV. We're going to be looking at the UV radiation spectrum today. So UV radiation is from about 100 nanometers to 400 nanometers. So that's the spectrum range of the UV area. And again, the nanometer is the distance from one peak of the waveform to the next peak of the waveform. So basically the size of the wave, if you would. So next, we'll see, once we're in this UV spectrum, that UV radiation is divided into 3 categories. We have UVA, UVB, and UVC. And really, this is just delineating the different sections of wavelengths. So that's just, it's different. As we go up, UVA, UVB, UVC, the wavelengths are getting tighter and tighter. In our normal daily lives, naturally occurring, basically, UVC is filtered out from sunlight, so we're really not exposed to it. which is good because it is very dangerous. Typically, we're exposed to UVA and UVB, 95% of that being the UVA spectrum. But as you can see from this chart that we're looking at here, regardless of which type of UV radiation we're talking about, it is in high doses, in intense doses, very dangerous stuff. It will, that's why we use it to disinfect. However, it doesn't discriminate. It doesn't care whether it's a pathogen or you or me. In humans, it can cause skin cancer, burns, lesions, etc., with extended dosages. So we need to be very careful how we're implementing this technology in a space where human beings are going to exist. So we have clean, sanitize, disinfect, sterilization. Is there a difference? Well, there is very much a difference from a regulatory standpoint. These are legal terms of art. So they are defined by some agency on what they exactly mean. So, sterilization and disinfecting, while we use them interchangeably at times, really aren't. They actually mean a specific thing. We're going to be really focusing on disinfecting, which is taking that pathogen or organism and making it ineffective, and doing that by making it not able to reproduce and changing its structure so it cannot infect another organism. So that's what we're really talking about here, is disinfecting. So one of the benefits of using a UV technology is that it happens without adding any harmful chemicals into the space. So you see here spraying down the surfaces. While it is an effective way of disinfecting the area, it leaves behind these chemicals, which are really dangerous to human beings, and they're residual and they're there. With the UV technology, depending on the strategy we use, we can mitigate or eliminate that danger. So what is disinfecting, and how's it work? So disinfecting, basically, we're taking this organism, the pathogen, whether it's a bacteria or a virus or whatnot, and we're eliminating its ability to reproduce. We're making it ineffective to infect other organisms. When we're talking about UVC, we're using the wavelengths from about 254 to 280 nanometers, which is, again, the tightest spectrum. And that UV energy radiation can penetrate the cell wall and goes inside and literally just starts to dismantle and reconnect the DNA in such a way that it can no longer reproduce. Again, which is really, it's really wonderful in doing that, again, but we really need to be very careful, because if we're exposed to it, it's going to do the same thing to our skin. It's going to go in there and start messing with the DNA in our skin. And again, nobody wants that to happen. That's really bad. So as James was alluding to, we have UVA and UVB and UVC. Typically, we use UVA and UVB in the disinfecting applications. There's a huge difference between the two. UVA, which is a broader span, contains much less energy in it. Also, it will not kill viruses. UVA will only be effective on organisms, on carbon-based organisms, which are those that contain DNA, which is bacteria, and it doesn't even kill all bacteria. But it will not kill a virus, which contains RNA. So that's a big point. And the other time, as you can see here, watt for watt, you need 1,200 times more energy of UVA, or higher dosage, in order to be just as effective as UVC. So typically, that's why we move to a UVC, and you hear so much about UVC, because its effectiveness in killing pathogens. So here's just a kind of an overview. There are pluses and minuses to both of them. One of the big plus, obviously, is we can kill all organisms with UVC. With UVA, we're not going to. It's going to cost a lot more money to power a UVA system as compared to a UVC system. But negatives is UVC is very, very easy, thankfully, to filter. So we have to be very specific about the types of materials we're using when we're controlling the UVC radiation, because with the wrong materials, we will eliminate the output of the fixture or the luminaire. And also, it doesn't bounce around the way a UVA or a visible light does. It just, when it hits the surface, it basically stops moving. Also, not while we have this radiation effect or the UV radiation we need to get to the pathogen, we also have to get it there at a certain intensity and for a certain length of time, because not all pathogens are created equal. So depending on what it is we're trying to remove from the environment, we need to know that and then design a system utilizing this technology to make sure we get the proper intensity and within a specific time frame. So area disinfection. How do we get this stuff into the environment or into the space? So not the only two, but two typical strategies are: we have a direct installation of UV sterilization, or an indirect UV sterilization strategy. In a direct UV sterilization strategy, as you can see in the picture, basically, and this is exactly where the Igor system comes into play significantly, is we lock down the space, we have occupancy sensors, we have redundancy to make sure that if a person steps into the space, it'll turn the fixtures off or not let them in the space at all. So where we have a building control system to do that, and then for a certain period of time, radiate the system and kill all of or disinfect the surfaces. The other type here we have here is an upper air hybrid area lighting system. What we can do is we can incorporate UVC elements in the indirect component of a luminaire, and that can create through convection currents and the air passing through the area between the top of the fixture and the ceiling, a disinfection zone. So the air can circumvent through this, being disinfected as it does it. So it's a continuous disinfection. The benefit here being obviously that the air in the room is always being disinfected. So with the lockdown method, once you're done disinfecting, if something walks in with a pathogen on it, the space is infected again, right? With the hybrid type, we can continuously disinfect this area to keep it safe. This is what the components look like. They look like regular LED boards. Pretty much, they come in the Zaga standard and different outputs, and you can see here we're using different units of measure, again, because now we're out of the visible spectrum of light and into the radiation here that we're talking about. Then we also have these optics that we can incorporate with these LED components to shape the UVC or the UV radiation coming out of the fixture, the UVA coming out of the fixture, to control based on what the need of the particular project is. So in a conversation, figuring out what it is we're trying to accomplish here, we can implement these different tools to create a system that's going to be effective for the particular design at hand. Here's an example by taking using this optical control. You can see on the right, we have basically the bare LED component just kind of radiating into the space. And on the left, we're using these lenses to focus it. And you can see in the results, we're getting 2.5 times the radiation levels in the controlled example as in the uncontrolled example. So we're delivering the UV radiation exactly where we want it in the dosages that we want it. So that's really important. And you can notice here, again, the units are changing. As opposed to using foot candles or lux, now we're using milliwatts per meter squared. So it's that's like your luminance level now is our radiance level. That's the units that we're using for that. So it's a little bit different. Same idea. An example comparing UVA, we were just looking at UVC. So UVC, we're getting 250 milliwatts per square meter. Here with a UVA system, you notice that the irradiance levels go way down. So we're not even hitting 1 milliwatt per square centimeter. So UVA, as we were talking before, 1,200 times less effective at disinfecting. So that's why it's has a limited use. Here we kind of look at the passive air system that we talked about. So here, what we're doing is we're using a direct or a direct-indirect luminaire, and on the indirect component, we're incorporating these UVC elements and shining them above the heads or above in the area above the occupants of the room, so they're not affected by the detrimental effects of the UVC radiation. and then through natural convection, the implementation of fans possibly to move the air in the room, or augmentation with additional floor-mounted UVC units that would clean the air as well. We can continually disinfect the space while people are entering and exiting the room. So if new pathogens are brought in and are left in the room airborne, we can disinfect them out, as you know, through the movement of the air through the UV radiation area above the fixtures. And as it brings out here, this has been done for quite a long time without any problems, as long as it's implemented correctly. And here again is just kind of a graphic representation of how we would go about doing that. And the colors show you the intensities and the locations of the UVC radiation. How we validate we do this, right? So, okay, so this is great stuff, but it's totally not a one size fit all. It is not just, you know, you go down to Home Depot, buy a fixture, throw it in, and you're good to go. I mean, there's a lot that goes in behind this. So we have tools to help us with this. We have a proprietary UV lighting designer. Consider this AGI for UV. We use this with our partner, Future Electronics, who we work with in this. And basically what this does is we put in the size of the room, the fixture, the performance of the fixture, et cetera, et cetera. And what that does, it gives us a similar output. It tells us what the radiance dosage is going to be. It's going to tell us the safety of the installation, of whether it meets certain standards. There's a report that was done in Europe a few years ago that kind of gives us our benchmarks of what is and what is not safe as far as UV radiation here, and also will give us a table showing what it is this installation will protect us against. It'll give us the pathogens that's effective against. Also, it'll give us the radiation levels, or the disinfection levels up to a log 4. So that's the standard 99.9%. 99.99% is what's considered standard in a medical installation, that we want to remove pathogens to that percentile. And how long it's going to take to do that based on the type of pathogen it is. So it gives us a sense of that our designs will work. Additionally, we have ways of looking at the types of fixtures that we currently produce and how we can install certain components into them and how effective they're going to be. Basically creating an IIS file, if you would, for this application. And again, it puts out these type of results where we get the report plus the graphics, so we can present this to an end user and say, you know, we're confident that what it is we're talking about here is going to work, that it is going to be effective to do what it is you want it to do and what you're paying for it to do. And again, here's just another example of that. So we want to thank you again. It's a lot of information, obviously, to cover in 15 minutes and 8 seconds. So if you would, if you have any questions, ask now, or also feel free to contact your ORA salesperson.
Steve, really, really interesting stuff. The couple questions. What is the rated life for the UVC boards? And the follow-up question is, does it require its own driver in the fixture? And do the fixtures look any different when they're off or when they're burning than standard products?
The boards, I'd have to go back and check. Rick, are you still on?
I am.
Okay, hey, Rick. This is Rick is from Future Electronics. We work with them on this. Do you know what the the L70, the L50 on the White Cough linear boards are?
I do. They it does depend on the temperature of the environment, which does have an impact on the life of the LEDs. But typically, L70, which is when the fixture reaches 70% of its original output, is typically somewhere between 20 and 25,000 hours of operation, and L50 is somewhere up between 50 and 60,000 hours.
Okay, thank you.
Gotcha.
So yeah, then and the other questions about the integration within the fixture. Typically, there are limitations of what we can do due to the size of the components, because the lens board configuration is about 2 inches wide. So, you know, it really is a case-by-case situation. Typically, no, we don't want the fixtures to look different. We incorporate them so they maintain their architectural integrity. But again, you know, there's always going to be some manner of consideration because again, if we have a 4-foot fixture, we might have to take a foot of normal LED out to put the UV light in. But it's always going to be typically what we do is on the indirect component, not the direct component, because obviously you wouldn't put this on the direct component.
As far as the sources being on a different driver, they definitely are on a different driver, and that's actually a benefit when you're talking about the PoE applications we discussed before, because you want potentially independent control of your visible light and your UV in cases of like Steve mentioned one time on an earlier call, where somebody may be getting up in the ceiling to maintain, do some maintenance or something. You want to be able to turn off the UV portion so that you're not exposing anyone there.
And so I was just thinking through some of these things on what Cheyo said and what you've said. Is it possible to think now that you could have a cable or pendant hung direct, indirect luminaire, 2-circuit on an inverter, or probably on a generator? I'm thinking now if it's going to be on PoE, but maybe not, and still have a non-6-inch diameter cable coming into that fixture, the building systems and the control. Is that a fair question? I'm just trying to imagine the benefits of this technology, and then like Beth asked earlier, how much of this are you going to see once you put it all together?
Well, with the PoE, with linear systems, again, that basically every, if it's a pendant mounted fixture, every 90 watts of consumed power or one of these nodes you're going to be bringing something into the fixture. What that something is, you're talking class 2 wiring, so you're not talking about, a 3/8 inch SJ cord, you're talking something, a much slender, manageable size. So, we've seen applications where we've taken it and actually use like a very slim, remember the reports you used to do when you were in high school, the older people that had like the little white thing on the side of the clear vinyl cover, kind of putting that around the cable and run the wire through that. Yes. So it stays tight and neat. But yeah, that is definitely a challenge with PoE, or one of the things we have to consider with PoE is there are going to be more drops, yes, you can put them all in, I guess, at the front end, but then you can end up with kind of a drain pipe with stuff going on.
Simple solution: lower the ceiling, flush mount the fixture. So yeah, Kevin,
recess is great.
where are these usually located in healthcare facilities? So that's a good question.
It could be used anywhere. I mean, you could use it in a patient room. You could use it. I mean, I know Carl was talking about he had some I guess a bank installation that he was thinking about. So it's not, while it is obviously, we always kind of think healthcare. The idea is we actually can go beyond healthcare with this. And I think with everything we've experienced over the last year, that's where a lot of people are going to start thinking, going, yeah, you can make me sit in a box. I want to be in the healthiest box I can be in, right? So this is one way of reaching that goal.
So assuming great success on a PoE installation, if you had to put, I got 2 different questions going in my head at the same time. If you had to get an email that simply stated what they wanted to achieve with using PoE and using the ultimate sanitizing system, is there a simple, okay, just send us what you would like to do with an RCP and we'll sort of give you the recipe? Or what would be the ideal package you receive to start engaging someone's design with these technologies?
I mean, that would definitely be the way to start, obviously, is with, like we would with any lighting design challenge, is send us an RCP. What is he looking to do? I mean, if they're, what the use of it, what the use of the space is, so we have an understanding, what it is we're trying to achieve. If there are any particulars as far as, is it a clean room or a classroom or, public space,
sure.
Things of that nature. So we have a sense, and then with that, Future is very helpful with us, and we can get on a phone call and say, okay, let's kind of drill through it, and then start working something out for you.
Well, I'm a really, really fascinating subject. If anyone has any other questions, obviously these gentlemen are accessible individually, although we of course would like to have you come through ORA or your rep to ask additional questions. And if you have any application questions, of course, we'd love to jump in with that. It's a lot of information for 4:47 on a Thursday afternoon. Thank you, gentlemen, both for what you've just pitched. And now to sort of lighten the load, we're going to jump into the last piece of our presentation, which is the ORA Chit Chat Challenge. As a lot of you might know, we challenged 3 design firms to accept a blind challenge similar to our first 3. And basically what happened was they agreed to receive a box and not know what was in it. They were going to get miscellaneous components plus a mission to fulfill using only their design skills and the contents of the box. 3 teams were agreed to jump in. They received their boxes, and we're going to share the reveal now of what was in those boxes. Carl?
So, welcome Observatoire, also known as our housing and building crew in the new world. Thank you once again for accepting this mission. As you know, in preparation, we have shipped over a supply box, which you have in front of you, and it's huge, to prepare your request. Now is a good time as any to open up the box, and when you do, please look for an envelope and read the instructions aloud for us.
Legio lends itself to many perspectives, including 3D. These Lego-like building blocks bring versatility and endless combinations to create free-formed, rigid structures and original designs that are playful, flexible. Every space needs a voice. Let the language of Legio do the talking.
Greetings, Observatoire. I'm Kristen McKenna, commander of Cheyo US, broadcasting to you from Mission Control in Houston, Texas.
Yeah, amazing. We have more of these than the light fixtures itself. Are these?
I know. So 2 weeks, but remember, the world needs you, and thanks you.
The mission. To complete your crew's headquarters by utilizing the theme and products available. This should include a logo representing your core skill sets and design concept for your lobby to match with the paired factory. You'll have 2 weeks to complete your mission. Oh, Barnlight!
Oh, that makes sense because I saw the little shades. Okay.
Ooh, okay.
Hello? Hello, can you hear me? Dash Lighting Design, on behalf of all mankind, thank you for accepting this mission. This is Princess Jennifer from Barnlight Electric, stocked with the last of the dwindling wood resources, including oak, ash, maple, and pine. Perhaps offering wooden accents would stoke memories of planet Earth on our new and alien home. Help us, Dash Lighting Design. You're our only hope.
Oh, cool. I was like, this can't be everything they have because it definitely is something used for the project.
Yeah.
Great. Lots of pop rock.
Yeah, to be honest, I don't know that I need furniture. So that's really
Orange?
Mine tastes like watermelon.
Oh, I think you're right.
Yeah. These are so good.
You guys.
Looks like you were gonna get your hair, Ileana. I was nervous about your hair.
Oh, it's the Aura Lumen
2021 Odyssey. The journey begins now. The mission to complete your crew's headquarters by utilizing the theme and products provided. They should include a logo representing your core skill sets and a design concept for your lobby to match with a paired factory. You will have 2 weeks to complete your mission. Your crew, energy and sustainability. Your partner, data lighting.
Yay. Cool.
As ambassadors of energy and sustainability.
Welcome to Dado. I'm Dave. Congratulations on accepting the 2121 Lunar Challenge. We look forward to working with you.
Great, Scott. Let's go.
Roger that. Roger that.
Great, Scott. Scott. Great, Scott.
Okay, we got some confetti. This is. Oh, we have small pictures. Nice.
Yeah, these are like, I was going to say, where's our fixtures? Thick as drywall.
Feed your creativity.
Oh, look at that.
Oh, is that astronaut ice cream?
I will send them to you.
Thank you.
Yeah. We need
one. Dang, awesome. This is too fun, you guys.
We here at Data Lighting are excited to be working with you.
And there you have it, all that and astronaut ice cream. We are going to be sharing as these projects develop. They're going to take some video of themselves building and designing, and then we're going to share the reveal with everybody in a couple of weeks. Hope you find the interest in it. We think this is tremendous amount of fun and a nice break from your regularly scheduled Zoom meetings. With that, I would like once again to thank our speakers, Cheyo, and with Igor and Steve Seligman and all the participating manufacturers. We thank you all for your time always. It's very, very important to us, and we want you to know that we are respectful of it. If you have feedback in any way on the time of day we do the presentations or what days we do them on, it means something to us to collect that information and respond. You can send your requests or your information to questions@orashorts.com. This concludes our shorts for this week. As a reminder, we have our library of shorts on the YouTube page if you want to go back at any point and reference what you saw. We're updating our Pinterest page every month with application images that might help you in your fixture selections and designs. And we're really happy you participate in this, and we think it's great for us. It works. So until, oh, sorry, here it is. Legication, guys. Legication's middle of March. Mark your calendars. We're going to skip shorts because of Legication. You're going to get an invitation from us for our Platinum Tour, which still is going to happen. We've got some surprises for you in store for that as well. And now I'll say thank you again for chiming in and checking us out.